Mr. Murphy here. Shout out to the new microphone. We're talking about the seasons today. This is something that we've spent a day in class doing, a day or two, depending on what time you have me. We spent a day online doing it as well. If I told you a one-word answer, why do we have seasons? You'd say tilt. Well, it's kind of more so of like, what does the tilt cause? We graphed the day length and noticed that the longer the day is in the summer, or excuse me, the longer the day is, we know that that's going to dictate what season it is. It's going to be longer in the summer, shorter in the winter, and we know that the seasons are opposite. But let's dig a little bit deeper today. Okay, so we got some notes that go with this. Yours are digital. You can also print them off. And we got two big essential questions today. What causes day and night? What causes our seasons to change? Day and night's super easy. So what causes day and night? It's caused by the rotation of Earth's axis. That is going to be kind of the first note that you have. So day and night is caused by rotation. And I'm hoping that this is a science experiment. That you can't hear this because I have the external microphone now. It used to like make a click sound. Okay, this is fun. And then we know that one day is obviously equal to 24 hours. Okay, cool. Great. Moving on. Why do we have seasons? We have seasons because of tilt of the Earth's axis. Okay, think of it like this. Can you guys see this? I hope so. We know that Earth has a tilt on its axis. We know if we're looking at this giant circle on the board that the North Pole right now and the South Pole are like so. Let's say the sun is over here. Hey, I get to be the sun. Do we notice that the North Pole is closer to the sun? Hey, look at me. I'm the sun. Hey, hi, sun. And then the South Pole. Because of that tilt, we can tell what season it is. And let's bust out the globe to find that. Let's see if I can figure this out. All right, cool. So we know that Earth is tilted. If this is the sun right here, the South Pole's closer. So it would be summer. The North Pole's farther away, so it would be winter. Think of the North Pole as kind of like where we should be looking on this. So if we look at this picture right here, let's change to, I don't know, green. This North Pole right here, that's supposed to be an N, people, is located closer to the sun than the South Pole, so I know that it is summer in the Northern Hemisphere and winter in the Southern Hemisphere. So looking at this, so this would be summer, okay, and I'm talking about the Northern Hemisphere right now. You know why I know it's summer? Because I can see that the North Pole is located closer to the sun than the South Pole, okay? Imagine here's the equator, cutting this thing right in half. The bottom is further away than the top. Now, what that means is we get more direct or indirect light. What does that mean? Okay, so in the summer, this gets to be my sun now. The north half is tilted towards the sun, which means, and let's hope that you can see that, we get more direct light. So imagine it like this. I'm shining this flashlight right here. You can sort of see it like that. Oh yeah, you can see it well. So when I have it perfectly up and down on the globe, notice that the outline that I make of my light bulb is, I don't know, like that. You with me? The most direct light. Now you can see that there's like kind of a halo that goes around it, but it's not very big. Not a very big circle. If I tilt that, do you see how the angle grows? I can see it. It's working. It's growing like crazy. Well, this means indirect light or less heat. So when it's perfectly over the top, we have direct light and more heat. That would be like noon. That's why it's warmest at noon, because you have most direct light or direct sunlight or direct thermal energy that day. As the sun gets lower in the sky or more indirect, there's going to be less heat. So in the summer, we get the most direct light, and in the winter, we get the less direct light, which is why it's warmest in the summer and coldest in the winter. And in the spring and the fall, we kind of get an in-between, which is why it's an in-between season. That makes sense, right? Keeping going here. So again, now we're in the winter. Okay. The summer, we get that perfect direct light. In the winter, the sun doesn't get as high in the sky. So we have the most indirect light. Again, noticing, looking at the shadow there. Indirect here, direct here. Man, I hope this is making sense. At the very least, I'm having a great time making this video. But think of it as like the flashlight. When a light bulb is directly over you, you can feel it. It's the hottest. If I turn it, it'll rotate. We're going to do something in class Wednesday or Thursday, depending on when you have me, that does a really good job of explaining that. So if you're an A student and you're watching this at home and you're like, I'm still really confused, I hope that tomorrow we'll go over it. If not, you can always Schoology message me and stuff. Okay, let's move on. So we know that we started over here in winter, or excuse me, in summer, and we've now gone to the spring. Just so you know, after the winter is the spring, in case you forgot. That was a joke. And now we're moving into the winter, where the South Pole is closest to the sun and the North Pole is further away. And of course, we're going to finish with the last season, of course. And it looks like that. So think about it. During the summer in the northern hemisphere, the sun appears smaller than at any point in the year. This is also the hottest part of the year. So the day length changes, but also the amount of direct sunlight changes. So if there's two things that tilt causes a change in day, and it also causes a change in direct sunlight. During the summer, the sun gets the highest in the sky, so it's the furthest away, so it's actually going to look a little bit smaller. Notice it like in the winter. If you look outside the window right now, it's like cloudy all week. But you'll see that the sun at 12 noon isn't that high above the sky, so it's giving us that indirect light. In the summer, it's super high in the sky, giving us more direct light. Now, and I don't think I need to explain this anymore, the seasons are flipped in the northern and southern hemisphere. It says if it's summer in Dallas, then it's winter in Rio de Janeiro, Brazil. Okay, solstices. So a reminder, you have a vocab quiz. This is two terms that I don't think I did a good enough job talking about in class this week. So we have solstices and equinoxes. They are the longest or shortest day of the year, and the sun reaches its highest or lowest point in the sky at noon. Remember, guys, you are filling these out as we go. So we're talking about the solstices right now. So we could say that right now it's the highest, or excuse me, it's the longest or shortest day of the year. The sun reaches its highest or lowest point in the sky. And I would like you to write this down. We're talking about the northern hemisphere right now. The summer solstice or start of summer, the longest day of the year, is always going to be June 21st. And the winter solstice is going to be December 21st. These are the start of the winter and summer seasons, and are also the longest and shortest day of the year. So I always think about like this, Mr. Positive, right? We just had the longest, let me start over. We just have the shortest day of the year. Well, every single day until summer, June 21st, the days are going to grow longer. Every day is getting longer. The sun's out longer. It's almost spring. And I really like this little diagram here. So this would be the summer solstice. We are chilling right up here in Columbus, Ohio. And notice the top half of our globe, the North Pole, is closer to the sun. So the sun would be like chilling way off over here. Of course, this is not to scale, people. That's a horribly drawn sun, but you get my point. And during the summer solstice, which is really crazy, and I'll show you some videos in class, the North Pole is actually in 24 hours of sunlight. In Ohio, we're going to get like 15 to 16-ish hours of sunlight. In northern Michigan, or in a place called Scotland, which is way over here that I was here a couple years ago, the sun didn't set till like 11 p.m. around the 4th of July, and the sun came up at like 3:15 in the morning. It was kind of crazy. In Ohio, around the summer solstice, the sun's going to set at, 9:45, 9:30, and the sun's going to get up at like 6. The sun's going to get up. The sun's going to rise. Now, the opposite, right? So if it's summer in the northern hemisphere, it's winter down here. Notice the South Pole is going to be in 24 hours of darkness. If you remember the penguin video I showed you where they're cuddling together, that was around 24 hours of pure darkness, so towards the winter solstice. Okay, now, it says Alaska is famous for going days at a time without sunlight. Predict when this would occur. That would be in the winter because it's opposite. I'll show you videos tomorrow. Winter solstice. Like I said, we just talked about it. Now we're in for a really short day. So this would have been December 21st for us, and that's like where the sun rises at like 8 and it sets at like 4:30-ish. I don't know, sad face. We're right here. The South Pole's in complete sunshine because the seasons are opposite, and the winter solstice is in complete darkness. Equinoxes, okay, new kind of deal here. Equinoxes are the start of both spring and fall. They are equal. Get equinox, right? Equinox, equal. Okay, cool. And this is where kind of the whole world, no matter what season it is all going to be sharing similar amount of daylight hours. Now, of course, temperatures are going to be different, climates are going to be different depending on where we're at. But in terms of sunlight, day and night are equal. And here's what's kind of cool. I thought this was an interesting fact. So now we adjust our clock based on like daylight savings and all this time. So during the Middle Ages in Europe, you basically took the day and you cut it into 2 parts, 12 hours of day and 12 hours at night. So the length of an hour varied with the seasons. So imagine it right now. Like the sun comes up at, I don't know, 8 o'clock. It sets at 6, let's say. So we would take those 10 hours and then we would split them into 12. So an hour would really only be like, I don't know, what is that, 50-ish minutes? That's kind of weird. Hard to keep track of. And we talked about it in class. The calendar was super messed up during the ancient Roman times, and Julius Caesar is actually the one who gets a lot of credit for kind of changing the way that we keep track of a year. Okay, so these last couple slides, guys, are just kind of some big questions. Making sure we should know by looking at this model, hey, I can tell exactly what season that is. I'm looking at the Northern Hemisphere. I know that right here, okay, on number A, or letter A, that's not a number, thanks Mr. Murphy. The North Pole is closest to the sun, so that's going to be summer. And if we're going this way, I know that after summer comes fall, and after fall comes winter, and notice that, you know, the North Pole is tilted further away from the sun here. And then obviously after winter comes spring, so I can look at that diagram and go, oh, that makes sense. And again, a couple things. Using the model of the Earth's revolution around the sun, describe why the seasons change, what causes day and night. These are just some big picture questions, and we'll take a quiz on it here in the future. And lastly, if you have questions, please reach out to me. I hope you really enjoyed this video. I rambled for probably about 8 minutes, and there was about 4 minutes of education in this, but that's okay. I aim to please. You're watching this at home on either Wednesday or Thursday. Hopefully my mic didn't cut out and this is all perfect. Great. Have an awesome day. It was a privilege to deliver this lesson to you. Get 8 hours of sleep. Go outside even though it's cold. And drink lots of water.